We can also use ratios for scaling. And scaling is going from like the actual ground where you can walk from one place to another to a map, which we show in a smaller region. And if we want to know the distance between point A and B on this map, we can measure it. And usually what you would do is take a string and kind of trace out the path so that it follows the path exactly, and then take the string off and measure how long the string is. And that's how you find that this distance here is 3 inches. So between these two, and then down on the right, you can see we have a scale, which tells us for each inch, that represents 5 miles on the ground. Okay, and that's a scale. And so we want to know the actual distance between the 2 points. So if we're doing that for this map, we can use a ratio, and what we would do is decide if we want to say inches on the numerator, then we would do miles on the denominator. And so I'm just going to write myself a little key, and I want you to get used to doing that. So we'll write inches because it helps you keep your information straight. So over miles. So inches to miles, that's what I'm going to look at for this map. And we know the scale is 1 inch to 5 miles. And so I put them in the same order as what I wrote for my key. And then I will write an equation. So I'm going to say that will be the same thing, that map ratio is going to be the same thing as for 3 inches. So the 3 will go in the numerator because it is in inches. And we already said inches goes in the numerator. So the 3 inches, and then we don't know how many miles. So that's where we'll put in a variable x. And now, just like our proportion equations before, our ratios, we would like to solve for x. And so to do that, I'll just multiply both sides by the product of the denominators. So 5 and x, so that'll give me a 5x. And you can think of it as being over 1 that I'm going to multiply on both sides of my equation. So I always want to multiply both sides by that quantity. I'm going to see if I can move myself. Oh, there's my red pen. Mark off the 5s because they reduce on the left-hand side, and on the right-hand side, those x's reduce. And then on the left, I have an x times 1, which is just x. And on the right, I have 3 times 5, right there, 3 times 5. So that's going to be 15. So x is 15, and so I have to ask, what does that 15 mean? Well, if I come back and look, my x was in the denominator, so I can track it back over. That was miles. So it's going to be 15 miles. So the question was 3 inches on the map between points A and B. How far is that in miles? So I can say points A and B are 15 miles apart. So one more question about this map, and that is, if you wanted to go on an 11-mile hike one day, what distance would that be on the map? So we need to use that same scale fact that we had, which was, and we wrote it before as inches to miles, and so we can do that again. So in this case, we still know 1 inch is equivalent to 5 miles on the map. That's our scaling factor. And we want an 11-mile hike. So I'm thinking 11 miles. So that's going to need to go in the denominator. So 11 in the denominator. And we want to know how many inches it will be on the map. So that's where I'll put the x in the numerator. Now this is different than our last equation because the last one had an x in the denominator. And that's fine. We could rearrange our equation. And I'll just show you that real briefly. You could put miles over inches if that helps you see things better. And then your equation would be 5 over 1 instead of 1 over 5. And then it would be 11 over x. And then everything looks just right on this one. Okay, so that's one way. If we just wrote it this first way, this is fine down here, but I'm not going to continue with it. We'll just say that's an alternate way of working this problem. But I want to show you what you can do without having to rearrange. So if you have 5 for one denominator, 11 for the other, we're still going to just multiply those two together. And I don't even need to know what their product is, just that I want them multiplied. So I can just say 5 times 11 over 1 on the right-hand side, and a 5 times 11 over 1 on the left-hand side. And then I can get my red pen out again, and on the left, my 5s are going to reduce, and that's why I don't bother multiplying it, because they'll reduce right away. And then the 11s will reduce on the right. And now my next line is going to be just 11 times 1 here on the left. So an 11 equals, and on the right I have 5x. I can see that is all that's left there. Now I want the x all by itself. So I'm going to undo that 5 that's in front of it, and I have to think what operation is between two things when they're smashed up together, and that is multiply. So to undo a multiply, I have to divide. So if I have 5 times x, I need to undo by doing divide by 5 on both sides of my equation. So that's undoing the 5 times x. And coming up here, red pen on the right, my 5 over itself just reduces to a 1, and so then I have 1 times x. On the left, it looks like that's not reducing at all because I have 11 over 5. Green. There we go. So my x, I'm just rewriting in the opposite order. So what was on the left is now on the right, and vice versa. So I have x equals 11/5 of an inch. And I know it's inches because it's in my numerator. And if I track over, my numerator is definitely in inches. So it's of an inch. And I'll say what it means represents 11 miles. 11/5 is an improper fraction. The numerator is bigger than the denominator, so I could just do 11 divided by 5 on my calculator, and I end up with 2.2. And so I could say it as 2.2 instead of 11 over 5 inches. And probably 2.2 is a better answer for this problem because that gives you an idea that there's 2 inches plus just a little bit more. So there's an 11-mile hike.